Hey guys, in this session let us learn how to deal with high CPU usage at a basic level. So here the scenario is application team observes some hang in application due to some reason and they are asking us to identify the cause of the hang. In general, there may be multiple reasons for the database or application to get hang. It may be due to resource shortage mainly, like CPU shortage, memory shortage, IO waits, and you can also include network latencies. And if there are high concurrent processes spawn, then also there may be a hang. So there may be multiple reasons. We'll see CPU usage hang in this session. So I have already executed a script which is very resource intensive. So once the application team complains or if you get some alert, so in general you'll be having some monitoring tool set with some threshold. So it may be 85% high, something like that. You will get alert in your mailbox. So based on the configuration, we have to immediately log into this server which has high CPU consumption, and the first command that you type is top. Okay, so this top command may vary depending on the flavors of Linux. So there are multiple flavors, right? IBM AX, HP UX, Itanium, and Solaris, CentOS. So based on the flavors of Linux, you may have to check the documentation and use those commands. And even the outputs may vary depending on the Linux flavors. But most of them would be using Linux systems. So we'll see how we can identify the CPU usage. So you have to check two columns: load average and percentage CPU. Load average has three columns. First one is last 5 minutes load, second one is last 10 minutes load, and the third one is last 15 minutes load. Okay, so mainly you have to check last 5 minutes load. You can see in last 15 minutes you have only 1.8 percentage of load, and last 10 minutes you have only 2.3, and but if you see the last 5 minutes, it has increased compared to the last 10 minutes and last 15 minutes. So you can see an exponential growth from last 15 minutes to last 5 minutes. So this means that your system is heavily loaded. So if you want to nail down the CPU consumption, if you want to confirm whether the CPU is exactly high or not, you can check percentage idle. So this is very important column. Why? Because so you will be having good experience in your servers. So you will be knowing better than anyone, right, in your project. So in some systems this load can be normal, but in some other systems this load can be abnormal. Based on your CPU capacity and workload, you have to calculate the CPU consumption. Okay, so you can see US, SY. So these are all the users in the OS. US means if there are any software installed in your server, if those softwares has any specific users, then they come under user. System means root processes. So whatever OS users which are running will come under system. Okay, so if any of the user, here you can see PCP. So this PCP is an OS user. So you may have some third-party softwares or Linux jobs running, scheduler jobs running in Linux. So those jobs will have a particular user and they come under system, which is OS user. But here the only software that we installed is Oracle, right? So that's why under user we have to consider Oracle processes. Okay, and you can see this idle percentage is consistently 0 for a quite long time. Just observe it. Even though you have very less load here, so in some systems this may come up to 100 200, 300. Last 5 minutes load may go up to 300. So in those cases, you cannot compare two servers, right? Because those workload can be different and their server capacity may be high. So in those cases, that may be different. But in this server, we don't have high capacity. We have only one CPU core. So let me show you how to check that. So for one CPU cycle, your load is very high. So that's why you need to drill down or connect the dots to identify the high CPU usage. Okay. So now you can see the percentage idle has come to 90%. So if this percentage idle is high, then there is no issue in the system. But if it is getting low consistently, then your system is under contention. So here in top process output, you have to check the consistent process which is on top. Okay. So sometimes, so there may be some processes which may immediately come up and go down. So those processes you can ignore, but you can see 5920 is the only process which is consistently consuming high CPU, right? You can see that. It's not even going down. But if you see other processes, see this K worker processes, so this process come up, but it may immediately go down. So it will vanish. See, it went to 4th. And you can see some other process, KSWAPD. These are all Linux process. Okay, now you have identified the particular process which is consuming high CPU. I will open another session. So here the process which is consuming high CPU is Oracle user, which means that the issue is from database side. Okay. So if the root process is consistently consuming high CPU on the top, then you have to tell the OS team or system admin team to look into it. So now we have narrowed down the issue by identifying whether the issue is from OS level or database level. Okay. So you have another command, ps-evo tcpu. So this command is also very important. You can keep it handy. You can check the first 5 process. So you can see that Oracle is the only process which is consuming almost 60% of the CPU. Okay. So you have a lot more parameters or values that you can specify. You can say terminal, from which terminal this command is executed. So you can see the documentation or man page on this command. Okay. So now let's log into the database and identify the process which consumes high CPU. So we already identified that 5920 is the process which is consuming high CPU. You have already learned how to map the OS process ID with the database PID, right? So we can use that learning over here. I will join $v session and $v process. First I will identify the user ID or the session ID. So I will map s dot session address, so it should be p address. with the and p.spid is equal to 5920. So this process we have already identified, right? So here I should give the alias let me check if I have any process called 5920. Okay, now the process has changed. Okay, so in real time also you may end up with this kind of behaviors. So don't get overwhelmed. You have to again check the process. So it is 6658. It has changed immediately. So now, so you just keep these queries handy so that you can immediately identify the process. It is 6658. Okay, now we have identified the session ID and serial number, and username is sys, but in real time this may be some other application user. Okay, because application user will be running the DML statements or select queries. Okay, so this is one scenario where application queries consume high CPU. Okay, so these kind of situations happen when the server has very less capacity. Okay, this may not happen always, but if the workload is quite high than the capacity, then you will observe these kind of behaviors. Now we have identified the session ID. So we will say that this session is consuming high CPU. Now we can drill down the SQL ID. You can say sq.sql. It should be s.sql ID. You can directly get the text, okay, instead of checking the SQL ID. sq.sql text from $sql sq, where s.sql ID is equal to yes. So I should join this. Is equal to sq.sql ID, and s.sid is equal to, we have this 68. Okay, so now we identify the command or the statement. Okay, so this command confirms that the statement is from application side. So, okay, so even still you can get more details like program, s.module, s.terminal, all these details. You can also take s.action. These will be even more helpful in confirming that whether the process is executed from application side. Okay, so you can see terminal is PTS O, and it has been executed from SQL plus. Okay, so now we have identified all these details. Now once the application team confirms that whether we can kill this session or not, after their approval we can kill this session, because if it is a production hour, then we cannot run non-critical jobs during production hour. Sometimes application team mistakenly execute or test some queries or statements in the production. So we can confirm with the application team whether this query is quite critical or not. Then we can go ahead and kill this session like this. So what is the SID? It's 68 and 35356. So if the application spawns more sessions, and if the parent session is not killed, then there may be multiple child sessions get triggered. So in those cases, you can directly kill the process from OS level, so which will be recommended. Okay, if the process ID is 6658, so you can do like this directly. Okay, so this is how you identify a high CPU usage session and kill that session. Okay, so this is one of the scenario. So there are other scenarios where the database job itself will consume high CPU. So those kind of scenarios will be like Arman backup execute during non-business hour. Second one is stats job consume high CPU. So this is auto stats job. Okay, or some other segment advisor, any of the auto task jobs. So these jobs are quite resource intensive, so they also may consume high CPU. So we will see these in another session. Okay, so now once the application team confirm, we kill the session. So if the process do not get killed, if the child processor keep on spawning, then you can kill it from OS level. And how you will check whether you have the sufficient CPU capacity or not? So you can see from OS level using /proc/CPU info and grep CPU. But in reality, you may be having either VM or physical servers. Okay, so in those cases, based on the number of hyper threads that you are having in your system, those CPUs may be utilized. Okay, but if the CPU cores are quite low and if your workload is too high, okay, how you will check if your workload is high? You can see the load average and the idle percent. Okay, if these two are quite high, then you can confirm that the CPU capacity is not sufficient to handle the incoming workload. So now I will again run this update. So from database level, you can check show parameter CPU. So here you can see CPU count is 1, and you can see parallel threads per CPU is also 1. Okay, so you have to multiply like this. So let's do that. Select 1 into 1 from dual. It is 1. Obviously your CPU if you multiply both these values, the result will be 1, right? So you have only one CPU which can be utilized. Okay, so if in some systems you may have parallel threads per CPU as 2. Okay, say for example, if I have CPU count as 4 and parallel threads per CPU is 2. So how you will calculate? You can multiply 4 into 2, which is the amount of parallel that you can use in your system. 8 parallel servers can be spawned. Okay, so this is how you calculate at the database level.